Alright, let us look at a question related to the proving of identities. We have been given tan theta plus secant theta equals L, and we have been asked to prove secant theta is equal to L square plus 1 divided by 2L. Given secant theta plus tan theta is equal to L. Now there is a key concept that we need to know here, which is we are aware of this identity secant squared theta minus tan square theta is equal to 1. But what flows out of this is secant theta minus tan theta times secant theta plus tan theta is also equal to 1. Which means we can write secant theta plus tan theta as the reciprocal of secant theta minus tan theta and vice versa. So this is what we are going to be using here. We have been given secant theta plus tan theta is L, which essentially means secant theta minus tan theta would be 1 upon L. Now if you add these two equations, these two terms will get cancelled and you get 2 secant theta is equal to L plus 1 upon L, which means 2 secant theta is equal to, if you take the LCM here, you will get L square plus 1. And therefore, secant theta is equal to L square plus 1 divided by 2L. This is what we have been asked to prove. Alright, let us look at another question in trigonometry related to the proving of identities. We are given sin theta plus cos theta equals P and secant theta plus cosecant theta equals Q. We have to prove Q into P square minus 1 equals 2P. So if you look at the left hand side here, there are specific terms. There's Q and there's P square and there's minus 1. So what we will do is first we will find out what is P square. Then we'll subtract 1 from that. That will give us this term in the brackets. And then we'll multiply it with Q, which is secant theta plus cosecant theta. And let's see what happens. So first P is equal to sin theta plus cos theta, which implies if I square on both sides, I'm going to get sin square theta plus cos square theta plus 2 sin theta cos theta. Now I'm going to apply minus 1 on both sides, which means sin square theta plus cos square theta, which we know is equal to 1, plus 2 sin theta cos theta minus 1. So I can cancel this minus 1 and the sin square theta plus cos square theta, which leaves me with P square minus 1 is equal to 2 sin theta cos theta. Now if you observe, we have already obtained an expression for P square minus 1. All we need to do is multiply it with Q, which is secant theta plus cosecant theta. So now we say Q times P square minus 1 would be equal to secant theta plus cosecant theta times 2 sin theta cos theta. So let's multiply these terms. So the first is 2 sin theta cos theta times secant theta plus 2 sin theta cos theta cosecant theta. If you notice, cos and secant are the reciprocals of each other, so they get cancelled. Sin and cosecant get cancelled, and then you end up with 2 times sin theta plus cos theta. So on the left hand side we have Q times P square minus 1, and the right hand side we have twice of sin theta plus cos theta, and we already know that sin theta plus cos theta is equal to P. So this whole expression becomes Q times P square minus 1 equals 2P, hence proved.